of all, I am very much thankful to the organization and Niraj for giving me this opportunity. I shall speak on nanofertilizers and nanobioformulations for global farming. Probably you all know when any dimension, maybe length, breadth, or height of a particle is 100 nanometer or less, then it is called nanoparticle. And under nano size, particles show some unusual properties which we can exploit for our agriculture or for our farming purposes. There are enormous scope of this nanoparticle to use. You can use a sensor, you can use a tracer, you can use a carrier, you can use as coating, filters, magnet, barcodes, quantum dots. You can use it as pesticides, composites, emulsions, and definitely as nanonutrient or nanofertilizer, which I will be discussing today. Actually, nanofertilizers are made with nano-sized nutrient particles, which can be delivered to the targeted sites to allow release of active ingredients, keeping the plant nutrient demand, and used to improve the fertility of soil for a better yield, nutrient use efficiency, increase crop quality and productivity. Why we go for nanofertilizer? Because they have large surface area and high reactivity. They can penetrating better into the cell. They increased plant and microbial activities, resulted more nutrient use efficiency. They are the effective catalyst. Actually, they are working as catalyst of plant and microbial metabolism, and they triggers the enzyme release. That is very important. That chemical fertilizer not do it. That triggers the enzyme release. So they are making plant active. What nanoparticle can do? We can use the nanoparticle for soil health management, for abiotic and biotic stress management. We can use it for plant disease diagnosis and health management. Nanoparticle can be used for ecological investigation related to farming, and we can use definitely for plant growth and manufacture of agro products. When we are applying nanoparticle, what they can do? They can reduce the toxicity, they can improve the shelf life, and they can increase the solubility. When we are applying nanoparticle to the plant, they may control the pest, they may control the disease, they may control plant genetic modification, they may control post-harvest prevention of loss. You can use nanoparticle as nanosensors for diagnostic of for changes in soil health measurement and soil condition measurement. So you can use nanoparticle as nanofertilizer for remediation of soil and water and for soil improvement. So you can say that it is actually making environment, social and economic sustainability through enhancing optimization of soil, water and nutrient sources, through enhancing crop production, through enhancing nutrient fortification and yield enhancement. How nanoparticle can protect soil? You see, with using of chemical fertilizer, when we are using irrigation water, there is lot of nutrient loss. And if you look at the rhizosphere, soil microbial buildup is very less and less organic matter buildup. Again, nutrient use efficiency, you know, is very less. That is the main problem of fertilizer, and nutrient mobility is less. But if you shift to nanofertilizer, you see what is happening. Nutrient retention capacity in the rhizosphere is increasing many folds. Soil microbial buildup is increasing many folds. More organic matter buildup. Nutrient use efficiency is increasing, and nutrient mobility also increasing. Again, you see, when we are using nanofertilizer, here is the comparison of 5 years results. No input, I mean natural farming when you are doing, this is chemical farming situation, the carbon sequestration potential of soil, and this is when you are using compost, vermi manure or vermicompost, anything, any organic manure. So you can see when we are using organic manure, then at least 30%, 60% the carbon sequestration is improving from natural farming and chemical fertilizer. But if you use nanofertilizer also, you are getting more, almost 70% improvement of carbon sequestration potential of the soil. That way, you are enriching the soil as well as environmental carbon dioxide problem you can solve a little bit with this nanofertilizer application. It can protect air. How? When we are using chemical fertilizer with irrigation water, you know nitrogen loss, emission loss is there. But if you use nanofertilizer with irrigation water, you can see you can minimize the emission or you can completely control the emission. That way, it is protecting the air. Again, carbon nanotubes made from titanium dioxide nanoparticle can absorb and oxidize harmful gases produced from agriculture. You can see here, 1 micromole carbon nanotube became 5 micromole after absorption of carbon dioxide. 8 micromole nanotube becomes 15 micromole after absorption of carbon dioxide. So that way also this nanoparticle can help. It protects water. You see, when we are using agrochemicals with irrigation water, it is due to fast release that the retention capacity is not that much by the plants. So lot of seepage is there and groundwater is polluted. But instead of agrochemicals, if we use nano-coated agrochemicals or nanoparticles as agrochemicals, then the release is slow, it increases absorption, root absorption, and you can avoid easily the groundwater pollution. Now, nanofiltration can be used to treat wastewater for subsequent application in irrigation. It requires low operating and energy cost and uses only 5 to 30 bar pressure. So that is that you can very well use it. Nanofiltration removes nearly all bacteria and viruses, most organic matter, divalent ions, and up to 90% of the monovalent ions. Up to 90% of agrochemicals indirectly run off in the environment due to their uncontrolled application. That's why if we use nano-coated pesticide or fungicide, that can help control their release in soil and can reduce environment and health risks. Now, if you compare chemical fertilizer, why I insisting to go for nanofertilizer? If you compare it with conventional fertilizer, that is chemical fertilizer, solubility in case of nanofertilizer is very high. Improved dispersion of insoluble nutrients in nanofertilizer. Soil absorption of fixation is reduced in case of nanofertilizer. Bioavailability is very high. Nutrient use efficiency is high. That is very important point. Main problem of chemical fertilizer you can solve if you shift to nanofertilizer, this use efficiency, and saves the fertilizer resources. Release rate and pattern, you can precisely control extended effective duration of release. Actually, if you look at chemical fertilizer, the duration of release is only 3 to 10 days. But if you go for nanofertilizer, the release rate extend to 30 to 40 days. So that way you can help extended duration of release and loss, you can minimize the losses of nutrient. What is the main problem of chemical fertilizer or conventional fertilizer? They are highly prone to losses, pollution of environment, they are doing the pollution of environment, and they have low nutrient use efficiency. For example, nitrogen, what is the causes of low efficiency? Because they are losing through immobilization, volatilization, denitrification, leaching. Phosphorus, they are fixing with aluminum, iron, and calcium. They are always the similar size of particles, so they are competing with the silica in the soil. Potassium fixation in clay lattice. Sulfur immobilization, leaching with water, micronutrient fixation in soils. So this way, this is the problem we are facing now that you can overcome if you shift to nanofertilizer. You can see it, that use efficiency. This is, I compare with our biosynthesis nanonutrient with chemical fertilizer. You know, nitrogen use efficiency, if you put 100 kg to your field, you will get 30 kg effect. Only 30 to 35% use efficiency nitrogen. But in case of biosynthesis nanonutrients, we found that 80 to 85% use efficiency. That means 2 to 2.5 times more use efficiency you may expect. Phosphorus, 15% only use efficiency. So if you use nano, 4 times use efficiency you can increase. At least we are getting at least 60% on an average use efficiency. Potassium from 35% to 88% use efficiency. Sulfur again 4 times improve in use efficiency. And interestingly, all micronutrient chemical fertilizer that use efficiency is not more than 5%. Not more than 5% any micronutrient. So that use efficiency we can increase to 20 times. I mean, at least when we are using nanoparticle as micronutrient, then we are getting at least 82% use efficiency. So that way you can save your fertilizer resource a lot. So why nanofertilizer we should prefer? 30 to 100 times less required than chemical fertilizer. Requirement is less. 4 to 20 times more efficient than chemical fertilizer. Use efficiency is more. 2 to 4 times less costly. I'll show the calculations. How much cost is there? Control release of nutrient to match the uptake pattern. You can use a slow release of your nanofertilizer. No loss of nutrient due to accumulation. Improve in the solubility of insoluble nutrient in soil and effective duration of nutrient supply. You will get more time, so you need not have to apply frequently this nanofertilizer. Now, the nanofertilizer you can use from the seed sowing to the grain storage. In every stage you can use it. This nanofertilizer. For example, if you use as seed treatment, then it increases seed strength, promotes faster and steadier growth and germination. Nano silver coating on seeds can improve water absorption. You see, when nanoparticle coated seeds, we found that they are fungicide resistant, they can intake the nutrient inside the seeds, they are flood resistant, pest resistant, temperature resistant. Nanoparticle treated plants showed 73% increase in vegetable dry weight and 3 times increase in vitamins. Nanoparticles increase at 90% of drought resistance. Again, during grain storage, we have already got many types of sensors, nanosensors. For example, carbon dioxide sensors, acoustic sensors, that from sound you will be able to know that your metal is spoiling, water sensor, from the smell, pressure sensor, temperature sensor, humidity and dust sensor. So these are the sensors now ordered in the market. So you can use it for grain storage. All are nanosensors. Now, so what nanoparticle made solutions? They can use for sustainable water use, treatment of seeds, pest and disease detection, enhance nutrient delivery and plant protection, remediation, reduce runoff. So what nanoparticle actually doing? It is increasing quality and quantity of yields and decreasing the soil pollution. Again, another important aspect of nanoparticle you can do with nanoparticle, that is nanobioformulations. It is the integration of biofertilizer with nanonutrient or nanoparticles. We prefer that biosynthesis nanoparticles is working better. In order to improve the better growth of the plants, the formulations containing one or more beneficial microorganisms enhancing soil productivity, maybe nitrogen fixers, p-solubilizers or mobilizers, plant growth promoting stimulators. So what advantage we are getting with this nanobioformulations? The shelf life and delivery of biofertilizer has been improved. These are the two problems of biofertilizer. One is shelf life, you all know, and another is delivery. So these two you can overcome. The release of active ingredient in control manner, you can control the release of nutrients, solve the limitation of biofertilizer. So we can solve the problems of biofertilizer, enhance stability. Biofertilizer stability you can increase, protection against oxidation, and consecutive delivery of multiple active ingredients. So how we can make it this nanobioformulation? These are the 3 instruments. This is not very costly instrument. You can do in your laboratory also. This is electrospinning. This is the called electrospinning. This instrument is electrospray, and this is nanospray. Either of any instruments can make this nanobioformulation with nanoparticle. So this nanobioformulation, you can make it as capsule where bioactives bioactive confined in the cavity here, or sphere, or you can make nanosphere where bioactives disperse in the matrix. So in the capsule, you see nanoparticles may be entrapped inside or may be surface absorbed. In case of nanosphere also, nanoparticle may be entrapped inside or may be surface absorbed. So what major advantage we will get with this formulation? Increase plant photosynthetic rate, promote plant growth, increase plant biomass, increase plant protein, extended harvest, reducing stress condition, accumulation of proline, synthesis of plant hormones, siderophore production, biological nitrogen fixation, phosphate solubilization, and mineralization. All these aspects, we are getting more benefit when we are making these nanobio formulations. Now, you probably understand the importance of nanoparticle. Now, how will go? How will manufacture in as an industry, or as by setting an industry? How you will do it? How will go forward? You see, first you have to have a clean laboratory, clean room. This is the international standard of clean room. Your laboratory should not have more than 10,000 dust particle per square meter. This is the international standard. If you have 10,000 or less dust particle in your laboratory, then it is a good laboratory. If you have 1,000 or less than dust particle in your laboratory, then it is very good laboratory. And if you have 100 or less dust particle, then it is excellent laboratory. Now, again, you have to wear, when you are manufacturing the nanoparticle, you have to wear nitrile gloves, mask, even a spray. During a spray, you have to wear nitrile gloves or masks, because so far we don't know long-term effect of nanoparticle, because they can penetrate from anywhere. So how it will behave in future, that we don't know. That's why, for safety point of view, and these nitrile gloves, the nanoparticle can't penetrate. That's why you wear these nitrile gloves and masks. Then go for the synthesis of nanoparticle. You can go for physical synthesis, you can go for chemical synthesis, you can go for aerosol synthesis, or you can go for biological synthesis. The important physical method people are using, the grinding, thermal evaporation, sputtering, pulse laser deposition technique. I am giving on example only. Here, for example, in case of phosphorus nanoparticle, we are preparing phosphorus nanoparticle through physical grinding method. You see, first we are purifying the our rock phosphate rocks, and then we grinding with ball mill. When you are grinding with ball mill, we are getting 20 nanometer size of nanoparticle. When you are grinding with port mill, we are getting 70 nanometer size of nanoparticle. So that very easily you can do laboratory, this physical method, this grinding method, you can use it. Only thing, you have to have a ball mill or pot mill to do it, and purification methods you have to know. And then chemical method. This important chemical method people are using is Sol-Gel method, polyvinyl pyrrolidine method, micro encapsulation technique, sonochemistry, microwave synthesis technique. For example, in case of zinc oxide nanoparticle, you are preparing the laboratory by taking zinc acetate, reacting with KOH, and then starting at room temperature, and we are getting zinc acetate, zinc oxide, white nanoparticle powder. Then aerosol technique, or mainly engineering people are using this aerosol technique, because for aerosol technique you have to know some engineering know-how, you have some machinery know-how, you need it. There are different aerosol methods people are using: furnace method, flame method, electrospray, chemical vapor deposition method, physical vapor deposition method. For example, by using carrier gas flow, we are preparing magnesium nanoparticle by using magnesium salt solution and changing carrier gas flow, heater size, and diffusion dry size. We are getting different shapes and sizes of magnesium nanoparticle. But all this method, this physical, chemical, and aerosol method, the particles are naked. So unless and until you coated them, they are immediately agglomerating and becoming nanoscale particle or megaparticle. Probably you know the difference between nanoparticle and nanoscale particle. Nanoparticle, the size is less than 100 nanometer. Nanoscale particle, the size is 100 to 1000 nanometer. Actually, the nanoscale particle is good for engineering and medicinal purposes. They don't bother for nanoparticle. Nanoscale particle is good enough for them, but for agriculture purpose, we need a particle as smaller as possible, because our particle should enter through our leaf stomata or cuticle, so that hole is very narrow. So that's why we need a particle which is naturally encapsulated. Therefore, we have developed this method, biosynthesis nanoparticle. This is our patent. This first time we have developed in the world. This is biosynthesis technique. What we are doing is we're isolating the organisms from the native soil. Then their spores we are taking to prepare a micellar ball. You see, this is micellar mass we are preparing. This micellar ball, we are allowing this ball to release the protein. You know, this allowing the release the protein, and that protein to break the desired salts into nano, like this. You see, this protein is actually breaking down the salts, these enzymes, and into nanoform. So this is in short of the method, and this is a patent number, and details if you want I can give you. So this is the beauty of this method. You see, this is the beauty of this method. This means the each and every particle are naturally encapsulated with mother protein. This is a mother enzyme, because it is microbial source. So mother protein is naturally encapsulated. You see, each and every particle. That's why they are naturally coated. So unless and until this protein layer breaks, they are stable. So we found that at least at normal room temperature, this protein layer, at least for 1 to 2 years, they are stable. So that is enough for our agricultural use. So that way, you can use this nanoparticle as liquid form directly, or you can prepare if farmers want, they can solid. Sometimes they like solid fertilizer. You can make it solid like this. This liquid nanoparticles. Then you go for oleic acid with xylene and stir for 1 hour at 50 degrees centigrade. Then you do centrifugal separation of modified particles, and you wash with toluene and dried under vacuum at 50 degrees centigrade, and you will get the nanofertilizer. So you can use as liquid fertilizer, you can go for solid fertilizer. But one thing I should say, that liquid fertilizer is better rather than solid, because during this process, due to this oleic acid coating, you may get your size. If I have seen normal nanoparticle size, you are getting 25 to 30 nanometer. After when you are making solid, you may get 40 to 50 nanometers. So the size is increasing during this fertilizer formation. Now, we have so far developed 73 organisms which can actually their protein you can use for preparation of different nanoparticles needed by the plants. This is some of the examples. This protein, asparagine protein, you can prepare zinc, magnesium, phosphorus, iron nanoparticle like this. This, for example, rhizoctenia particular protein you can use for zinc and phosphorus nanoparticle like this. So this is some other examples. So total 73 organisms we have so far developed, producing different nanoparticles, all types of nanoparticles needed for agricultural use. So now, after production, so you know the production, you know the laboratory condition what you have maintained. Now you know how we can go for production of nanoparticle. Now after production, what is the next step? Is the characterization of your nanoparticle. So in your laboratory, you must have this instrument, particle size analyzer or dynamic light scattering. This is the most important instrument in the nano laboratory, because this instrument can give your average nanoparticle distribution, average nanoparticle size, polydispersity index value, means whether your nanoparticle is monodispersed or not, you will be able to know, as well as zeta potential value. Zeta potential value will indicate the stability of your particle. Though these three things is very important: your average particle size, your monodisperse of your particle or not, as well as your stability of your particle. So all these things you will be able to know with the particle size analyzer. Then second instrument people are using transmission electron microscope. This exactly measures the length, breadth, and height of your particle. Next instrument people are using is scanning electron microscope. Same, it will give you how you looks like, how your nanoparticle is looks like. Maybe it is U shape, whether it is flare shape, whether wire shape, case shape, whether it is circular, whether it is sphere, that you will be able to know how you will look like that through same scanning electron microscope. Then another instrument people are using, that is atomic force microscope, AFM. They are functioning same as TEM. Either you have TEM or you have AFM. Only difference is they are also measuring the exactly length, height, and breadth of the particle. But the only difference is TEM and AFM, they are giving beautiful three-dimensional structure, AFM. Then another instrument people mainly are using in the laboratory, mainly research institute, that industry people, they don't need it, of course, FTIR. FTIR is mainly used to identify the functional group, which functional group is responsible for nanoparticle protein, which is absorption, which is group is responsible for desorption. So that I think industry is little interest on it. Next instrument people are using X-ray diffraction. That is another instrument you can identify the nanoparticle from the X-ray peaks. So that instrument you may have. If you don't have particle size analyzer, you may have X-ray diffraction. Then another instrument also industry should have, EDS, energy dispersive X-ray spectroscopy. That is another very important instrument that will give you purity of your particle, how much pure your particle is. So industry must have particle size analyzer as well as EDS, electron energy dispersive X-ray spectroscopy, because the purity also very important for release of a particular product in the market. Then another instrument people are using is lithography. Mainly engineering people are using, because to make prototype through this lithographic technique, you can make same prototype, same another duplicate of particle. Again, two analytical instrument people are using for nanoparticle laboratory, that is inductively coupled plasma mass spectrophotometer, ICP-MS, and ICP-OES, optical emission spectrophotometer. You see, the two instruments, both the instruments are very sophisticated. The only difference is ICP-MS is more sophisticated. They can measure up to 0.6 ppb level, parts per billion. So each and every particle they can trace, where it is going, where it is forming. So everything you know if you have ICP-MS, and ICP-OES up to 20 ppb level they are measuring. So this is the only difference. So I'll show you some of the photographs of our biosynthesis nanoparticle. You see TEM image of our iron nanoparticle, biosynthesis iron nanoparticle, phosphorus nanoparticle, how it looks, zinc nanoparticle, magnesium nanoparticle. This is all TEM image. You see here, the particles may be cube shape. This is called plate shape particle. This is called wire shape particle. This is called case shape particle. So your particle may be different shapes, different size, and different phases you may get it in particle. This is some AFM image. You can see beautiful three-dimensional. This is our nitrogen nanoparticle, biosynthesis nitrogen, silver, potassium, gold nanoparticle. Some images, or this is all biosynthesis images. You see here that only three-dimensional structure we are getting in case of AFM image. Now, this is EDS that I am telling you. This is also very important instrument for the industries. You see, we find that our nitrogen nanoparticle which we are preparing, that is 96% pure, iron 93% pure, phosphorus only 67% pure, zinc is 98% pure. So from this EDS, you may measure the purity of your particle. So that is also very important instrument. Now, after preparation, you have now prepared your nanoparticle. Now application, that is another important aspect in agriculture. How you proceed? Actually, nanoparticle you can spray, you can apply as foliage, foliar spray. In the soil you can apply. You can go for drip, you can go for sprinkler, you can go for hydroponic, you can go for aeroponic, you can go for aquaponic. In any mode you can apply nanoparticle. But best is, we found the best way of applying nanoparticle is the foliar spray. And when you go for foliar spray, you use as fine nozzle as possible. If you have aerosol sprayer, that is the best. Nebulizer, if you have. We found why? We found that when you are using very fine sprayer, that is nebulizer, environmental loss is only 15%, and we could recover almost 85% nanoparticle. But 15% could not recover environmental loss. But normal sprayer, when we are using normal sprayer that we are applying now in the field, the normal sprayer, 33% loss is there in the environment. So definitely it is better when you use nanoparticle, it is better to have as fine nozzle as possible for spraying. Then the size matters a lot. We find that if your nanoparticle is 20 nanometer or less size, then they are penetrating better and they are most effective. They are very effective. But if size is more, I am showing you some results. When 20 nanometer size of nanoparticle, you see after 48 hours, 53% we have the spread on leaf, and 53% nanoparticle we find in root. That means 53% nanoparticle or within 48 hours penetrated from leaf to root, entire pathway. But if it is 40 nanometer size, then only 21%. If it is 60 nanometer size, only 11%. So smaller than nanoparticle, their penetration is better. Again, shape also matters. We find that if we have cube-shaped nanoparticle, they are penetrating faster. You see, we have the spread on leaf. Within 24 hours, 21% cube-shaped nanoparticle we find in root. So a cube-shaped nanoparticle penetration is better. Whereas if you have plate shape, only 8%. If you have oval shape, only 9%. If you have case shape, only 4%. So cube-shaped nanoparticle is always better. Then you can see we have optimized the concentration for all types of crops. What concentration we have used nanoparticles so that the plant does not injure. That is also very important when you go for foliar spray. We found that for cereals, biosynthetic nanonutrients, for cereals 80 ppm is the best. Nitrogen 80 ppm, legumes also 90 ppm, 80 ppm is the best. Phosphorus 40 is the safe limit. Potassium 40 ppm for cereal safe limit. Legumes 20 ppm is the safe limit. Magnesium 20 is the safe limit. Zinc 10 ppm. Iron 30 ppm. Boron 4 ppm for cereals, 10 ppm for legumes. Molybdenum 6 ppm for cereals and 2 ppm for legumes. So now, when we are applying foliage, what is happening? This nanoparticle can enter through shoot, through cuticle, stomata, hydrothetes, stigma, or other anticides, or through roots, root tips, rhizodermis, lateral root, and wounding. What is happening after entering? You can see it here. This is our own experiment here. The zinc nanoparticle entering stomata in mung bean. You can see here, this is the nanoparticle. They are entering it. You can see after entering, what is happening? They are moving. You see here, look at, they are moving through cell shaft. You see, this is our nanoparticle. They are moving through cell shaft after entering. So these, when they are moving, they are triggering different enzyme systems. That is the beauty of foliar spray. You can trigger the plant enzyme systems and release the beneficial enzymes through plants, and you can make more native nutrient mobilization. That's how we are getting better effect when we are using nanoparticles. This is the reason why we are getting more effect after a nanoparticle. After that nanoparticle application, after that you can see either they are absorbing in the cell, or we found that some nanoparticle is accumulating in the vacuole. So that is also a concern. Gradually, if nanoparticle accumulate in the vacuole, still we don't know after long term, after 10 years, 20 years. We know up to 5 years, no adverse effect. But after 10, 20 years, what will happen? That still we don't know. Long term studies going on. Now, how it is triggering? You can see this is another beauty of nanoparticle use. You see, this is the phosphatase enzyme structure. And if you look at the cofactor, magnesium, phosphorus, and zinc, these three are the cofactor of these phosphatase enzymes. So this is beauty. If you don't have phosphorus nanofertilizer, you can use magnesium nanofertilizer also to mobilize P, or to get more effect of P, because they can trigger phosphorus also. If you have zinc, that also will do. So this is the beauty of nanoparticle, is by applying one particle, you can get multiple particle effect due to this mobilization. And we found that this is this triggering, and due to this making plant active. You see, otherwise plant is lazier than us, I tell you. Plant is more lazier. chemical fertilizer, we are just placing the fertilizer and they are eating it and they are not exerting themselves at all. But here we are triggering their enzyme system and we are getting extra benefit when we are applying nanoparticle as foliar application. And here you can see 32 to 212 times improvement in different beneficial enzyme release. So here you can, I am showing you what are these average 10 crops. You see dehydrogens, this is the indicator of bacteria and actinomycetes activity in the soil. So dehydrogens activity is increasing 25 to 68%. FSRS, this is the indicator of fungi, bacteria, and actinomycetes activity in the soil. They are increasing 23 to 90%. Acid phosphatase, alkaline phosphatase, phytase, these are the P-mobilizing enzymes. You see 18 to 136% improvement is there due to this triggering, due to this nanoparticle triggering through foliar application. Nitrate reductase, nitrogen mobilizing enzymes, you see 12 to 47% increase. Aryl sulfatase, 19 to 68% improvement in sulfur mobilizing enzymes. Again, you can see the cellulase, hemicellulase, and lignase. These three are degrading enzymes. This degrading enzymes activity is increasing 23 to 212% improvement with this triggering. Amylase, break starch to glucose and maltose. You see 20 to 126% improvement. Chitinase, degrade chitin to carbon and nitrogen. You see 27 to 72% improvement. Lipase, that they are degrading fatty acid to sugar. 32 to 67% improvement. And protease, the protein degrading enzymes, we are getting 39 to 108% improvement with this triggering. So this triggering is help. That's why I tell you repeatedly that when you advocate farmers to apply nanoparticle, you advise them to go for foliar application so that this extra benefit we may get it. Now, the nanoparticle, you see, we have compared with chemical fertilizer here, the same amount of, same concentration of chemical fertilizer here. The protein content is improving. You see, from control, when you are using chemical fertilizer, 13%. In case of nano fertilizer, same 30%. Protein content is increased with nano zinc, nano iron. SOD activities decline. That is another important thing. You see, declining SOD activity, semi-oxide dismutase activity means plant become more stress tolerant. So if for arid and semi-arid areas, especially if you go for nano fertilizer application, you will get your plant more stress tolerant. They can survive 10, 20 days more without irrigation or without rainfall. Again, another important thing, the chlorophyll content is improving with nanoparticle. We have compared with chemical fertilizer. With nanoparticle, chlorophyll content increasing, and MDA activity, non-aldehyde content, MDA activity is declining. So less MDA activity means that prevention of membrane damage. That means nanoparticles working as antioxidant. So especially in leafy vegetables, for leafy vegetables, you can get more survival of your particles, many days more survival of your particles if you use a nanoparticle instead of chemical fertilizer. So now, another important thing we find that magnesium and titanium dioxide nanoparticle, they are helping the sunlight absorption to the plants. You see, sunlight, the chemical fertilizer, same amount of chemical fertilizer when we are using, 3% only improvement of light absorption, whereas nanomagnesium 21% improvement, you can see. Titanium dioxide, similar megaparticle 2% and nanoparticle 35%. So you know that more improvement of light absorption means more chlorophyll content. So we are getting more chlorophyll content in the leaf also. So now the stresses plant are facing. Plant are facing biotic stresses such as insect attack, pathogen attack, herbivore attack, as well as abiotic stresses, ultraviolet rays, cold stress, heat stress, heavy metal stress, salinity stress, drought stress, heavy rainfall or flood stress. These are the stresses plant are facing, and what these stresses are doing, that their abiotic stress are affecting primary metabolites and ultimately plant development, and biotic stress, it is mainly affecting phytohormones and ultimately it is affecting plant defense. Plant can't defend due to this attack, due to these stresses. So what nanoparticle can do? Nanoparticle, you can use nanoparticle as protectant against this pest, bacteria, fungi, virus. As you can see, already it is proved silver, copper, gold, titanium dioxide, chitosan. This nanoparticle can protect pest, bacteria, fungi, actinomyces. Or nanoparticle you can use as carrier of insecticide, fungicide, herbicide carrier. Silica, chitosan, this nanoparticle is good carrier for this insecticide, fungicides. So what benefit we can get ultimately? We can increase the shelf life of your particle, shelf life of your material. Site-specific uptake we can improve. Solubility we can improve. And we can declining the soil leaching that we can prevent, and toxicity we can prevent. So that way also nanoparticle help. Again, you can detect the biotic stress. There are many biosensors now in the market. Through biotic state detection, nanobiosensors, through nanobiosensors, through nanoimaging, through nanostructure platforms, through microRNA, through nano4 DNA sequencing tool, through quantum dots. So these all are very high sensitivity, very accurate detecting material, and high specificity. So that way also nanoparticle is helping to trace your stress condition of your plant. Again, these are the nanoparticles proved against different stresses. Against pathogenic attack, we have found that copper, silver, titanium dioxide, sulfur, gold, zinc, copper chitosan nanoparticle is helping. Against viral attack, silver and gold is helping. Again, insect attack, aluminum, silver, titanium dioxide, zinc oxide, silicon dioxide, and chitosan is helping. Again, nematode attack, titanium dioxide nanoparticle, zinc oxide nanoparticle, aluminum oxides, silver and silicon dioxide nanoparticle is helping. Against wheat attacks, silver, copper, iron, zinc, manganese, and silver chitosan is helping. Against moisture stress, you can go for zinc and iron nanoparticle. Salinity stress, you can go for selenium and selenium and cerium oxide nanoparticle. Temperature stress, selenium and silver nanoparticle, and UV radiation, silicon and silver nanoparticle is helping. So this is already proved. These are the nanoparticles already proved they are helping. Maybe other nanoparticles also helping. So far we don't know, but these are the nanoparticles it is proved to be helping to overcome plant stresses. Now, the nanofertilizer, how it is effective? You can see I am showing some of the examples only. 12 crops we have got results at least for 40 crops. We have both under research field and farmers field. You can see it here with the, for example, in case of capsicum, for example, P and zinc application, zinc nanoparticle application, we are getting 90 to 24% improvement in yield. This is all our biosynthesis nanoparticle. I am showing the results. You see, in all crops overall, at least 17 to 54% improvement we may get, and both the under research field as well as farmers field. Rather, we are getting better result on the farmers field than research field. Maybe due to that better management, I don't know. But always we find, if you look at the results that from different places, that farmers field result is much better than the results we are getting under research field. So now this is entire Rajasthan we have calculated, and that major crops, if you shift to nanofertilizer, what will happen? You see, this is the major crops of Rajasthan: palm millet, mung bean, cluster bean, cauliflower, and this is the area covered. And this is the present yield. You know, here mainly sandy soil, the yield is very poor. So this is the present yield, and we find that if we shift to nanoparticle, so it is at least 30 to 35% yield increase may be possible against this cultivar. So this is the overall picture that in entire state, if you shift nanoparticle from chemical fertilizer, it is possible to enhance our yield further. Now I am taking one example only with one nutrient. What will happen if you shift to biosynthesis nanofertilizer from chemical fertilizer? You see, in case of phosphorus, what is happening? Chemical fertilizer, we are using macrophosphorus, I mean bigger size P particle. Nanophosphorus, we are insisting that you go for nano P instead of macro P. What will happen? Here, in case of macro P, You see 0.73% native P in plant available form. You know, not a single soil throughout the world you will get phosphorus availability in the soil more than 3%. That is the problem with phosphorus. So immobile and so less availability in the soil. But here, if you shift to nanofertilizer, due to this triggering effect, the native P mobilization increased by 30% of P mobilization is increased. Here, 15% of applied P available to plant. You know, P use efficiency only 15%. But here I have already shown use efficiency, P use efficiency NS to 61%. You see, at least 4 times use efficiency. So that way you reduce your fertilizer dose, first in native P mobilization as well as the use efficiency is helping a lot to reduce your fertilizer dose. And again, you can see calcium, iron, aluminum, silica inhibits available P. I have already shown you that they are binding with the P, and silica, they are the same size, they are competing with the P. Here, no interference in case of nano due to nano size and foliar application. Here, less plant initiative to mobilize P. Here, increase in plant activity due to triggering of enzymes. They are triggering the enzymes, so they increase the plant activity. Here, you know, in case of preparation of fertilizer, we are importing raw material because we don't have good rock phosphate in country. So, resulting in drain of foreign exchange that way, and decline in government revenue due to subsidy. Government is giving huge subsidy to make fertilizer cheaper. Here, if you shift to nanofertilizer, no requirement of subsidy and import of raw material. So what after a benefit we are getting? 80 to 100 times less requirement than chemical fertilizer, less cost. We have calculated the with nano P, with biosynthesis nano P with SSP and DFE, 2 to 4 times less costly, 10 times more stress tolerant. Due to this, that enzyme activity, decline in enzyme activity, yield increase 23 to 54%. Eco-friendly, can be applied on all types of crops. Per hectare benefit we are getting 4,000 to 17,000 rupees we have calculated, and 32 to 212% increase in beneficial soil enzymes, improvement in soil health, no adverse effect. We have seen that no adverse effect with recommended doses of application, that I'll show the result also. Now, what nanoparticle again do? They can prepare polysaccharides, nano-induced polysaccharides. You see, this is the if we apply this nanoparticle with polysaccharide producing organism, this is the fungi, polysaccharide producing fungi. This is some polysaccharide producing bacteria. If we apply the nanoparticle to them, for example, zinc, when you are applying to them zinc nanoparticle, you see this is the basic polysaccharide production capacity, which is improving to this much, 10 to 12 times polysaccharide production, you may get it. So this is, we have developed a method, and this is my patent of this method, you see, for preparation of polysaccharide powder. We are preparing the polysaccharide powder from different bacteria and fungi. This is the polysaccharide powder we are producing. This polysaccharide powder, you can use as soil aggregation, moisture retention, and carbon buildup in the soil. I'll show you how much. Here, this is Josalmi soil. You see, this is sums. This is 95% of sand. This is nothing but soil, is nothing but sand only. So this soil, when you apply 1% of this polysaccharide powder, you see after 1 month, such a nice soil aggregation we are getting. So here, with this polysaccharide, up to 80% of 1 millimeter soil aggregate improvement is there, 82% 0.5 millimeter soil aggregate, and 56% 0.18 millimeter soil aggregate. So soil aggregation, especially in arid and semi-arid areas where it is the problem, aggregation is the problem, you can use this polysaccharide powder for soil aggregation, moisture retention, and carbon buildup. You can see the carbon buildup. You see, polysaccharide also carbon. So when we are applying 1%, 4%, 5%, immediately we are getting tremendous, after 7 days, if you see tremendous improvement of soil carbon, but gradually it is declining due to this microbial effect also. If soil carbon buildup, the microbial buildup also there. So you will get gradually less carbon buildup, but at crop harvest. That is the net carbon buildup you may expect 3 to 4%. So at crop MSC also we are getting 3 to 4%. That carbon buildup you may expect with the application of polysaccharide powder. And again, If you look at the moisture retention capacity, 1% to 5-6% of polysaccharide powder when we are applying, 10 to 15% moisture retention we are getting in under arid soil system. So these polysaccharide powder also very useful material for soil aggregation, moisture retention, and carbon buildup. Now, if you overall the potential nanonutrient effect, it can improve the environmental quality, it can improve the nutrient uptake, it can improve the water holding capacity, it can improve the soil quality, it can increase the microbial activity, plant productivity, and health. You can use it can reduce, when we are applying soil, it can reduce nutrient volatilization, it can reduce nutrient leaching. You can use this nanoparticle as foliage, you can use it as nanobioformulations, you can use it as slow release control fertilizer. Anyway, so number of ways you can use it and number of effect you may get it under soil plant system with the application of this nanoparticle. Now, if we compare the yield of different generation of fertilizer, I say the chemical fertilizer was our first generation fertilizer, second generation fertilizer was organic fertilizer, third generation growth stimulator or gluconate based product, and fourth generation is nanofertilizer. If you look at here, in case of chemical fertilizer, if you take average of world crop yield, you can expect 14 to 18% more yield. In any crop, you may expect 14 to 18% of more yield with the application of chemical fertilizer. If you go for organic fertilizer, 8 to 12% you may expect it. If you go for growth stimulator, 5 to 10%. But in case of nanofertilizer or nanobioformulations, we are getting more than 24 to 32% improvement in yield. So if you compare every generation of fertilizer, this nanofertilizer is definitely better than chemical and organic fertilizer. And again, if you compare the soil health, continuous application of 5 years, you see continuous application of 5 years in the same field of chemical fertilizer, the soil health is deteriorating. You see the health, soil health condition. But if you look at organic fertilizer, it is the best to maintain the soil health. Definitely organic fertilizer is soil health maintenance, it is the best. And if you look at growth stimulator, also it is also good. It is maintaining more than 60% of health index, so it is good. And you see, this is the nanofertilizer. It is better than growth stimulator, and it is almost equal to, if you look at nanobioformulation result, I don't have, but nanobioformulation definitely it is as good as biofertilizer in terms of soil health condition. So this nanofertilizer also maintaining soil health with recommended doses of application. Now, ethical issues, that is very important. I tell you that if you use recommended doses of application, it is very safe. You can see seed germination, this cluster bean, movement. This is 3 legume crops, this is cereal crops. You can see with ordinary fertilizer means chemical fertilizer, and nanofertilizer, nano zinc, ordinary zinc, nano iron, ordinary iron. So these 3 different nutrients, you can see no significant changes in seed germination. So no adverse effect of seed germination. If you look at soluble seed protein content, you can see no significant difference in all the cases. So chemical fertilizer also not affecting seed germination, soluble seed protein content. Nanofertilizer also not adversely affecting seed germination and soluble seed protein content. You see microbial buildup, microbial population. You see, in case of nanofertilizer, you can see microbial population is increasing, microfungal population is improving, bacterial population significantly improving, actinomycete population also significantly improving. So it is helping microbial population build up in the soil. Now, after harvest the consumption of grains and straw to the animals, what is happening in the mice? If you consume after consuming grains to mice, if you body weight, if you look at body weight is with nanofertilizer. You compare with chemical fertilizer and control no fertilizer. You can see it is slightly increasing rather body weight in case of by consuming nanofertilizer. If you look at consumption, it is also slightly improving. And blood pH, no significant changes. So nanofertilizer with recommended dose, no adverse effect even after 5 years. Now, if you look at the histopathological analysis, the NIN is doing, they are the authorized government body to sacrifice the animals. So they are doing, you see here, the liver kidney, spleen, after 5 years, even continuous feeding, you see negative effect. So no adverse effect with recommended doses of application. So recommended doses of application is very safe, but you must go for recommended doses of nanofertilizer application. You can't go for indiscriminate use like chemical fertilizer. Now, that unigenes, genetic changes, what genetic changes a nanofertilizer can make, you see, yes, in case of cereals, the some changes is there, some unigenes expressed differently with the application of nanofertilizer. 6,542 unigenes express differently in nanofertilizer when you using cereals. You see, some are down-regulated, some are up-regulated. But the advantage is with nanofertilizer that one enzymes known as endobeta-mannose is releasing when we are applying nanofertilizer to cereals, and this enzymes is helping for embryogenesis, seed germination, shoot growth, leaf formation, flower development, and fruit ripening. So ultimately, that's why we are getting better effect. In case of legumes also, many unigenes are changing differently. Some down-regulated, some up-regulated. But when we tested individual unigenes, their function, we found that they are helping 605 unigenes, these changes in unigenes helping carbohydrate metabolism, 237 unigenes helping lipid metabolism, 323 unigenes helping nucleotide metabolism, amino acid metabolism, and biosynthesis, secondary metabolism. So ultimately, these changes is positive, they are helping. So don't worry about these changes in genetic changes due to application of this nanonutrients. Now, your product is ready, then you go to market. For marketing, first you have to approach Nano Mission Council, NMC, or Nanotechnology Regulation Authority. You have to hand over the samples to them. So what they do is, they send the samples to Monitoring and Evaluation Committee. And they have some supporting labs, Indian Institute of Technology, Roorkee, and Indian Institute of Chemical Technology, that is at Hyderabad. So this, they are doing toxicological test and risk assessment. And they are sending their report to evaluation and submission test to Nano Safety and Advisory Committee, and they are passing their report to Nano Mission Council. Now, this Nano Mission Council, they are making the decision. Then if they approve your material, then your material and product is commercialized or can be used for R&D purpose. If they are not approved your material, then your material will be rejected. But in both cases, the material will go, the report they will send to CKMNT. Actually, this is the Center for Knowledge Management of Nanoscience and Technology, that is in Secunderabad. So then they manage the data, whatever the data they got, the management and for publications. So this is the, in nutshell, the regulatory framework in India. If you have nano manufacturer, if you are nano manufacturer company, or if you produce any nanoparticle, and then these are the nanomaterial manufacturing company now come in the market. You may get it this in the market. You can purchase it, the nanomaterial. Fortune Inc. Their product name is Nano5, and their product is slow release nutrients. You can use it as slow release nutrients. Agro Nanotechnology Corporation, their product name is NanoGrow, that plant growth regulator. You can use it. IPCO, their product is NanoUrea and NanoDAP, then nitrogen and P fertilizer. You can use it. Geohumus, their product name is Geohumus. Soil and water conservation, for soil and water conservation you can use this. Desert Control Inc., their product name is NanoClay, soil and water conservation. Hive crop protection, their product name is Alspars, their nanopesticides. Max System LLC, their product name is Nano Revolution 2.0. Their product is you can use it as nano herbicides. Then Nano World, their product name is Nanosensor, that can use precision agriculture. Then Forweg, their product is Nano Barcode, say identity preservation and tracking. Then Silco, they are nanocellulose. They are for garment industries, you can use it. And again, There are nano products for stress management. These are the companies, they marketed nano product for stress management. Syngenta, their product name is Primomax and Caredion. They inhibit neural system of the insect or pest. Nanogreen, their product name is Nanogreen. They attack respiratory apparatus. Agro Nanotechnology Corporation, their product name is Nanogrow. The mimics stress condition, increasing crop activity and yield. So these are the product already available in the market. So what we learned so far with this deliberation, what we should take home, that is nanofertilizer may prevent environment, that is air, water, soil pollution. That I think you all agree. It has the potential to reduce chemical fertilizer application and can compromise with biofertilizer. That is our additional advantage of nanofertilizer. They may compromise with biofertilizer. Nanofertilizer are very safe with recommended doses of application and can maintain soil health. That I have shown the results. It can increase the nutrient use efficiency and crop yield over chemical fertilizer, as well as draw more profit with much lower investment. It can protect the plants from biotic and abiotic stresses, and with nanobioformulations, it can help to increase the efficiency of biofertilizers. So thank you very much. Thank you for your patience.
थैंक यू सो मच सर. मैं आपका बहुत बहुत धन्यवाद करना चाहता हूँ. थैंक सर. मैं चाहता हूँ कि अभी जो भी पार्टिसिपेंट्स हैं एक एक करके हैंड रेज करें और जिनका हम यहाँ से नाम बोले वो अपने आप को अनम्यूट करें और अपना क्वेश्चन पूछें. और प्लीज आपसे निवेदन है कि कोई एक क्वेश्चन पूछ रहा है तो उसके बीच में आप बीच में अपना माइक ऑन करके उस पर बीच में उसको डिस्टर्ब ना करें. और मैं सर एक चीज आपसे जो पर्सनली जानना चाहता था, अगर आप हिंदी में भी बताएं थोड़ा सा, क्योंकि हमारे साइंटिफिक टॉपिक नैनो यूरिया के ऊपर जो भी इफको जो आ रही है उसके ऊपर आपकी क्या व्यूज है नैनो यूरिया पे, क्योंकि कुछ फार्मर भी है. नैनो यूरिया पे आप क्या कहते हैं?
Actually, you see, lot of research is needed on this product.
Okay.
So far I feel, because most of the product are not in nano size.
Okay.
You know that you have seen that mainly they are if you don't have particle size less than 20 nanometer or less, that penetration is less. So that's why you may get less penetration. Otherwise, I think that may help. Definitely, if it is nano size, definitely it will work. And if you go for foliage application, definitely you will get better effect due to this triggering of plants, and as well as you see use efficiency. And they should go for that research also on this. The use efficiency they have not mentioned anywhere. That what is their nano urea use efficiency?
मीन्स हमें नैनो यूरिया पे वर्क करने की जरूरत है, जो डीएपी जो अपना इफको का उसके ऊपर रिसर्च की जरूरत है.
Yes, काफी जरूरत है अभी more research is needed. Actually, I am sorry to say, but it is hurriedly they launch in the market. This is too hurry. Before that, they should do some this speed work. That especially the size aspect, especially the stability aspect, as well as their trigger that use efficiency aspect. These things are very important.
सर अभी हम क्वेश्चन लेते हैं. डॉक्टर जगदीश सर अपने आप को अनम्यूट करें.
Yeah. So excellent talk and very comprehensive and very much useful regarding nanofertilizers. We are very grateful the Jagdish sir. And I have a question. So this nanoparticle application, you said that it enhances the activity of several enzymes. Those are present in the plant like SODs, nitrate reductase, and all the other enzymes. Okay, but my question is, so if they are constitutively active, for example, after application of this nanofertilizer, these enzymes, okay, but in plant, so there is a limited amount of energy is produced, right? But these enzymes require a lot of energy, okay, activation. But does this affect the yield? Because there is always a cost benefit ratios, okay. So if they use a lot of this energy in order to activate these enzymes, how does it affect the growth and also the yield of the plant?
Actually, I have told you that nanoparticles have very good penetration power. They are penetrating very fast. So during penetration, they are actually triggering the enzyme systems. That I already showed how they are triggering. And then due to triggering, I think this during penetration, if you this is the actual compaction, dhakka laga diya. So this is the dhakka lagana hai. So they have the potential. You know, plants can't go beyond their potential. That is there. Suppose you have a mediocre student. कितना कोशिश करे फादर और मदर और पेरेंट्स, जितना कोशिश करे वो मीडियकर ही रहेगा उसको, बट वो उसका कैपेसिटी का मैक्सिमम वो कैन परफॉर्म कर सकते हैं. ये भी ऐसा ही है, ये भी ऐसा ही है. I don't claim that they are going beyond their capacity. Plant capacity is there. That's why we are getting only 30% mobilization extra, but not 60% or not 80%, because due to this plant capacity. So definitely plant capacity is a major factor, definitely one of the factor. It is, you are nicely pointed out that questions, and you see that, but we should trigger them so that their capacity they should release, otherwise they will not do. You see, in case of chemical fertilizer, when we are applying chemical fertilizer, they are just eating simply. Even if you look at, we have compare when we are using chemical fertilizer in the soil and when we are applying nano fertilizer through plants, we have seen that when we are using chemical fertilizer, no enzyme secretion from the plant root. But when under hydroculture experiment, but when we are using nano fertilizer through plant, then huge amount of release of enzymes, beneficial enzymes in the soil solution, on water solutions. So that is the difference. That's why the potential, definitely their potential will not affect. They release the nutrient as per their potential. They release the enzymes as per their potential maximum up to their potential, not that, not more.
So the not constitutively expressed, because plants have regulatory mechanisms. If an enzyme is constitutively expressed, okay, always it is a cost for the plant, right? Actually, so that's why plants have a regulatory mechanisms. For example, any pathogen comes, then only this SODs and all become active. If there is no pathogen comes, they do not active. Okay, but application of the nano fertilizer, how does this actually affect the, if the enzyme is constitutively expressed? So it is a lot of cost for the plant to invest a lot of energy in activating this enzyme even without any pathogen. So that's what my question is. Probably more research is required in that. And second, only one last.
Yes, but I tell you one thing. Sorry to interrupt. They at least to their potential effect we may get it, but whatever you are pointing out, definitely that more research is needed, that actually whether it is costing to the plant, that nobody knows so far, but at least we can trigger them up to their potential. If you are a good student, if you suppose student and parents relationship, if you compare that, I know that this boy can stood fast. If we can push them, he can stood fast. So that is the difference. Actually, we are pushing through nanoparticle to the plants. So these plants has the ability to release this much of enzyme, so that much they can do. But it is not that we are damaging the plants to do it. So that's why that's why the doses is fixed. We fix the doses where plant does not affect, plant are not injured with the application of this.
Okay, sir. Thank you. And Vishal Rana ji.
Hello.
Sir, namaskar.
Ji.
Sir, the nano urea is totally a novel product for farmers' point of view.
Yes.
ठीक है सर?
Yes.
तो अभी तक फार्मर्स को अडॉप्ट करने के लिए, ग्रास रूट में घुसने के लिए, फार्मर का उसका लेवल देखने के लिए उसके तक जाना पड़ेगा. हमें अभी भी जस्ट कि सर ने बहुत सारे मार्केट में अवेलेबल प्रोडक्ट्स हैं वो बताए हैं. हमें तो सिर्फ अभी इफ्को का ही पता था. इफ्को का यही बताया गया. इफ्को का एक हमारे डिपार्टमेंट में ही एक वर्कशॉप हुई थी. उसमें उन्होंने कहा था कि यूरिया का जो वन बैग है, दैट विल बी रिप्लेस्ड बाय 1 बॉटल ऑफ 250 ग्राम 250 ml. ठीक है सर, कह रहे कि ये करे. लेकिन फार्मर क्या सोचता है? फार्मर ये सोचता है कि उसको स्प्रे करने के लिए, फार्मर खुद तो स्प्रे नहीं करता, मेजॉरिटी जो है थे वो किसी को करवाते हैं. वो लगभग अगर 8 कनाल में 1 एकड़ में ये स्प्रे करेंगे, ये स्प्रे करेंगे तो लगभग 50 रुपए एक कनाल के लेंगे, 8 कनाल का 400 रुपया तो आ गया। ये 200-250 रुपए की बॉटल में उसका कितना 400 रुपया और कास्ट बढ़ गई। फार्मर कैसे अडॉप्ट करेगा? अभी तक तो हमें जो डोजेज हैं वो बताई गई हैं इसकी सिर्फ इसमें वीट और पैडी में, और इसमें बाकी डोजेज हैं। और एक और मेरा क्वेश्चन है, क्योंकि ये जो लिक्विड फर्टिलाइजर है ये सिर्फ तो स्प्रिंकलर के ड्रिप वाले इस्तेमाल कर रहे हैं, मेजॉरिटी इज ब्रॉडकास्टिंग, तो वो कैसे रिप्लेस करेगा? तो इस तरह का कोई लिटरेचर या पीपीटी हमें शेयर करे ताकि हम भी इसको थोड़ा सा इन डेप्थ नॉलेज लें और फार्मर तक इसका जो अडॉप्शन रेट है वो बढ़ाने में मदद करें।
एक चीज मैं क्लियरली बोलना चाहता हूँ, जो आपको नाइट्रोजन, पोटाशियम, दे आर वेरी मोबाइल, सो सॉइल में स्टॉक ज्यादा नहीं है। एक्चुअली नैनो फर्टिलाइजर जो मोबिलाइज कर रहा है, जो न्यूट्रिएंट मोबिलाइजेशन कैपेसिटी 30% मोर हम दिखाया है, उसके लिए तो सॉइल में स्टॉक होना चाहिए। फॉस्फोरस, जिंक, दे आर रिलेटेडली इमोबाइल, सो इनका केस में कोई प्रॉब्लम नहीं है। बट फॉर सॉल्युबल न्यूट्रिएंट, जो मोबाइल न्यूट्रिएंट है, उसके लिए लेकिन आपको सब्सिडी सॉइल में भी कुछ देना पड़ेगा, बेसल डोज देना पड़ेगा। नैनो न्यूट्रिएंट कांट ओवर completely I mean subsidize that chemical fertilizer. That is not possible in case of mobile nutrients. But in case of immobile nutrients, for example for phosphorus, for zinc, yes, up to 20 years, 25 years, if you don't apply any basal doses of phosphorus, still you can mobilize through nano. One thing. And another thing is जो आप उठाया है, जो डेफिनेटली दिस इज वैलिड क्वेश्चन, जो आप कैसे जो सॉलिड नहीं होगा तो अच्छा नहीं, दैट आल्सो आई हैव सीन इन द फार्मर्स फील्ड दैट फार्मर्स वांट solid particle rather than liquid particle. But I tell you, in case of nano, if you use liquid fertilizer, that is the best, because you can trigger the system, which is not possible when you are using solid fertilizer. Through drip you can do it a little bit, but through soil application, it is not that extra benefit, you may not get it. And again the आप doses जो उठाया है, जो इतना कम से कैसे होगा? Actually जो use efficiency, actually IFCO not yet tested their nitrogen use efficiency in their nano urea, as well as I tell you that the stability as well as their size. That if they can maintain the stability and size, and they can do that, they can do that part. Actually, the how much is absorption from the, how much fertilizer they should put in the soil basically, as well as how much should apply. They should mention, because 100% nitrogen, I mean you can't replace with nano, because nitrogen is a mobile nutrient.
Yes,
in case of phosphorus, I agree. In case of phosphorus, I definitely agree. Up to 20 years, you can do it without applying any chemical fertilizer. But in case of nitrogen, urea is a nitrogen fertilizer, and you can't do it. And concentration, they should increase their concentration in the solution. That work they should do it. That's why I'm telling more research is needed. Again, I mean on this aspect.
ओके सर हम नेक्स्ट क्वेश्चन लेते हैं, ज्यादा टाइम को हम लोग सबके छोड़ में। डॉक्टर विनय कुमार।
हेलो
जी।
Yes.
Sir, thank you so much for a nice presentation, and you have given a lots of information regarding the benefit of nano fertilizer. My question is, sir, is there any limitation of nano fertilizer?
Yes, there is limitation, because you can't, like chemical fertilizer, you can go for more doses also. If farmers see that it is also working, nano fertilizer you can't do it. Nano fertilizer limitations is fast. With the nano fertilizer, you have to provide nitrile gloves or mask to keep safe the farmers, because we still don't know the after triggering to your body. You see that some I have shown some slides that vacuole accumulation in the vacuole, that you don't know. That's why that is one limitations. And single limitations, you can't do higher doses. Higher doses we have seen, for example, in case of zinc, the 10 ppm is the optimum, the critical dose. If you use 30 ppm, 40 ppm, many crops are dying. because this is due to this higher dose. So higher dose you can't apply. Again, when you apply, you should wear nitrile gloves or not. These are the two things are very important. And third thing is for mobile nutrients. For immobile nutrient, you simply
sir.
with nanofertilizer, that is enough. For mobile nutrients, for nitrogen, potassium, you have to do some basal doses of chemical fertilizer, or here your biofertilizer can do a lot. You use biofertilizer as basal dose, I mean organic manure, and then go for nanofertilizer. That is the best way. Purely organic biosynthesis nanofertilizer you go, and you apply basal doses of organic fertilizer in your system. So that will be the best way to do organic farming, I think.
Okay, sir. Thank you so much, sir.
Okay, thank you, sir.
Okay. Balakrishna ji. Balakrishna ji. Viren Seth ji.
Dr. Jagdish sir, thank you very much for very power-packed presentation, and congratulations on your innovative product development for the benefit of farmer. सर मेरा क्वेश्चन ये है कि ये जो आपका कैरियर है वो हर जनरेशन के फर्टिलाइजर के साथ चल सकता है एज ए बायो फॉर्मुलेशन? नंबर वन क्वेश्चन. सेकंड, क्या ये एमएसएमई के लिए टेक्नोलॉजी अवेलेबल कमर्शियली हो सकती है और ये अफोर्डेबल है? क्योंकि जितने भी आपने नाम बताए सारे मल्टीनेशनल या रीजनल बड़ी कंपनियां हैं. इज इट पॉसिबल कि कोई एमएसएमई इसके अंदर कोई रोल प्ले कर सकेगा?
Yes, I tell you that to start with, you have to have a clean laboratory, that I told already, and you have to have two important instruments, that is particle size analyzer and EDS. These two things you have to have. And particle size analyzer is cost almost 25 lakhs. And EDS cost almost 10 lakhs. So 35 lakhs plus your clean laboratory as well as bioreactor for biosynthesis nanoparticle production. So at least minimum you should have 1 crore rupees to start with. I mean, then that is the minimum. But I can give you guarantee that if you spend 1 crore rupees, you can earn many crores with this after production nanofertilizer. That is possible.
क्या टेक्नोलॉजी कॉस्ट इसमें इन्वॉल्व नहीं हुआ है ना सर? ये तो बेसिक रिक्वायरमेंट हो गया.
And the technology cost, I think technology, from where purchase, I don't know that from where you want to purchase, or you can hire any advisor, those who knows the biosynthesis nanotechnology, and then they will help you.
So it is approximately 1.5 or 2 crore rupees of investment. MSME can be a viable to be market.
Definitely,
and it will be a cost effective to a farmer.
It is viable if you can afford initially. Then because biosynthesis technique is very cheap. You see, you are using only microbial protein, and if you identify the protein, then directly you can just with protein you use the salt and you prepare the nanoparticle. So it is very cheap method, but only thing, initial investment is very high because due to these instruments. You see, these two instruments is must, because that particle size every time you have to analyze, and then stability, zeta potential, you have to do it, and EDS, your purity of your particles. These three things are very important. So these two instruments you must have, as well as bioreactor for preparation of your biosynthesis nanoparticle. So that is there. So yes, definitely 1.5 to 2 crore is the safe limit. And you have to maintain the clean room. If you have clean laboratory, then it is good. Then that cost you can minimize.
Okay, sir. Thank you so much, sir. हम next question लेते हैं. बालाकृष्ण जी, आप कुछ पूछ रहे थे, आपका हैंड रेज था. बालाकृष्ण जी, आप कुछ पूछना चाह रहे थे, आपका हैंड रेज था जी. बालाकृष्ण जी, आप अपने आप को अनम्यूट कीजिए. अगर आपका कोई क्वेश्चन है तो आपका हैंड रेज दोबारा मेरे को दिखाई दे रहे हैं यहाँ पे. नहीं. ओके, आकाश चंद जी. आकाश चंद जी. आकाश चंद जी, आपका जी पूछिए.
आवाज आ रही है सर?
जी सर, जी सर.
Sorry.
Thank you very. First of all, thank you very much for arranging such a wonderful session with Dr. Jagdish. And sir, I am into the business of seeds, pesticides, and fertilizers since last 35 years. So nano fertilizer, the acceptance is still
far away from the reality. So whatever you are telling that this kind of investment, we can make this kind of investment. We need your guidance, sir, because we have a 1,260 farmer group, and initially we will manufacture it for our own purpose. We will use it. We will make the use case, and that we will publish. So if you are ready to guide us, then we are ready to make the investment.
Akash Chandra, I will share the email ID of Dr. Jagdish sir. You can write it mail, and surely he will reply. Okay.
Yes, definitely.
Okay, sir. Okay, thank you. Okay. O.P. Sharma ji.
Hello, sir.
Yes.
This is Dr. O.P. Sharma from NIPHM Hyderabad. My question is to Dr. Jagdish, sir. That recently one article was there, big article, and some Denmark university, they have conducted a study on the IFCO produced nano urea. The challenge that they are making means IFCO is making foolish to the farmers that it is not a technology, or it cannot be replaced the 45 kg urea bag with 500 ml of the nano urea, because they calculated the quantity of nitrogen which is in the 45 kg bag, that is 20 kg nitrogen, and in case of this 500 ml nano urea, liquid nano urea, that is only 20 gram. So when plant is absorbing, suppose both the things in separate fields or plots, then how it is replacing that 20 gram, 1000 means 1000 times more effective it is there. Means that nitrogen quantity from where it is coming. It is a very layman or simple question. Farmers are also raising this question, that how, from where it is replaced, what is the source of that? My question is, what is your opinion? I want to know.
Sir, that I am also telling that actually they should do some spade work before marketing their product, because they don't have the data of nutrient use efficiency of their material. As well as I told you, nitrogen is very mobile. They have pointed a valid valid point that actually where from so much, because nitrogen is not reserved in the soil. It is not phosphorus. Nitrogen is very much mobile, so their reserve is very less. That's why some visual dose is needed. So they may say, you may say that 25% of nitrogen can be overcome with this their nano urea, or 50% like this. So that thing they should do it. And as well as
1000 times urea, how it
not,
is
that is, yes, that is practically not
but
possible.
my question is this, sir, that the same question will be arising what the products you are suggesting, or whatever the other nanoparticles are there. For them also it may be suggested. There may be some improvement with nanotechnology and nano preparations. If it is 20-30% benefit is there, even that is good. Even 10% benefit is good, but they are telling that it is 1000 times more nitrogen. From where that means nutrient as nitrogen as a nutrient, from where it will come. So that same challenge may be with the products which you are suggesting.
No,
You have to think of that.
You see, for mobile nutrient, that's why I'm telling now, you can go in for input with biofertilizer and then go for nano. So biosynthesis nanoparticle. So you can exploit them, because you can take advantage of this use efficiency as well as the triggering effect, the nutrient, enzyme release from the system. So mobilization effect. So this will be definitely effective nutrient like phosphorus, zinc, because they are relatively immobile. So lot of nutrient, even if you go to SAMs, I have seen, I have collected samples from SAMs, and there also you will get more than 2000 ppm phosphorus in reserve with sand. So this can exploit. Regularly, this immobile nutrient is accumulating in the system. That nutrient you can exploit through this nano. So for mobile nutrient, you have to have some basal doses. Otherwise, you can't do with nano. You can't get the similar effect. This is not possible.
If it is recommended along with some organic or some
yes, that's
manures, then it can be justified.
They should work on this aspect, that this must you can replace. due to this use efficiency and this triggering effect. These two things they should, point out with their system. And another problem is that they should, the material should be stable at least for 1-2 years, as well as the size. Many nano-urea, many people showed me the results that they are not nano actually. They are mainly nanoscale particle. So nanoscale particle is good for, industry, engineering purpose or medicinal purpose. But in agriculture purpose, we need a particle which is really nano size. And if it is 20 nanometer or less, then you will get best effect. So we need nanoparticle, not nanoscale particle.
Okay, sir.
Okay, sir. See the challenge. It may come to other nanoparticles also or
Yeah,
biostimulants. Thank you,
sir. Okay. Gurumurthy, sir. Gurumurthy ji.
Sir, yes. Thank you, Dr. Jagdish sir, for a very good presentation, and really it is apt at this time. Dr. Sab, what is my view is in continuation of Sharma sir's one, as the crop plants in 1 unit area requires relatively high nitrogen content. But the marketing, we are recommending for 500 ml of the nano for 1 acre, as although we substitute through some other components, as you said, basal dose. But I feel strongly, as a soil scientist, it requires more nitrogen, because as you said many times in the previous discussion, the nitrogen in the soil is not a reserve, except a little organic reserve like a phosphorus or other potassium or micronutrients. So how much it can be substituted? What my serious observations in this, after thinking, only 26 grams of the nitrogen would not compensate or substitute for about 46 kgs of the urea, or even a 20 kgs of nitrogen. A crop as a whole, what we supply through the fertilizer, maybe about 20 to 25%. The other contribution for the crop would be the remaining 75% is biological nitrogen fixation. Take rice an example, 1 acre. So the crop may require, as far the uptake is concerned, around 175 to 200 kgs of nitrogen. Of that, we will be supplying only a little quantity through the fertilizer on a different stage, split application. But nano fertilizer will be having just 26 grams, as far they consider 80% efficiency also. It is not meeting a limited. Maybe spraying 1 nano fertilizer will give you like what we spray urea for a drought conditions or some other condition to make it a few availability. Then other part, one thing I think I am telling you how short it is, and second one is
डॉक्टर गुरुमूर्ति सर, मैं चाहता हूँ कि थोड़ा संक्षिप्त में रखिए, क्योंकि टाइम हम लोग ऑलरेडी 1.5 आवर से ऊपर हो चुके हैं. थोड़ा सा प्लीज टू द पॉइंट रखिए डॉक्टर साहब.
Yeah. The point may be, sir, what I was feeling, because it is a compliment for your presentation, rather we can say, not a shoot.
You say you itself can calculate the use efficiency. You can improve from 30 to 35% to 80 to 82% with nano. So 2.5 times there you can save. And second thing, that mobilization maximum you can, in case of nitrate reactors, it is 16 to 20% extra mobilization, or on an average, if you look at 30%, that much mobilization you can have. So rest you have to input. That is there. So that way you can calculate. Definitely 26 grams is not enough. You have to, you can use efficiency, that amount you can reduce. 2.5 times more use efficiency, that 2.5 times fertilizer you can remove. If you have 100 kg you need, then it may come 40 kg. That much is okay. And then again, 30% more if you can mobilize. Of course, if you should have in your system that much nitrogen, because nitrogen is very mobile. I don't know whether you have in your system, then 30% more you can mobilize. So that much also you can cut it. So hardly another 30% means you can at least 28 kg material you need it.
Okay, sir.
Instead of
Yes, sir.
100 kg,
Okay.
you can claim 28 kg. For 28 kg, you have to at least 20 kg you can as an organic fertilizer or chemical fertilizer you have to put in your system, and then you can go for nano fertilizer. That one can calculate.
Yes, sir. This is,
Understand
as
this?
you said, 100% correct, because even then it requires a huge quantities of the fertilizer, chemical fertilizer. It requires
Chemical fertilizer
nano
or
is a-
organic fertilizer.
Nano is a supplement, not a substitute. It is a
Yes,
supplement. And
not
second one,
100%. Supplement, yes, not substitute.
yeah, that's very important, because
And
people are claiming that one 500 ml of the nano bottle or nano liquid nano is substituting the as you said 50 kg urea. It's not correct, as you said. And the second one is those crops, 1 minute, that's up 1 minute, those crops which require less nitrogen, like legumes, or those soils which are relatively rich in the organic matter content of the nitrogen, there I think 1 or 2 sprays of this nano fertilizer may give a optimum yields. That's a chance. That is a chance. I think what are the reports we are receiving, nano also will be playing a good role on those legume crops, and as well as those soils which are rich in the organic matter content may do well. That's what actually my view. Thank you, Dr. Sir.
Thank you, sir. Thank you very much, sir. Damodar sir, Dr. Damodar ji.
Sir, good evening, sir.
Good evening.
Sir, myself, Dr. Damodar Chari from NIPHM, National Institute of Plant Health Management.
Okay.
Sir, my question is, these nano bioformulations are applicable to whether completely organic farming or integrated nutrient management practices or conventional farming, these are compatible?
Yes, they are always compatible. And you can save the biofertilizer, because the problem of biofertilizer you are facing, that you can overcome with the nano bioformulations. And that is not very costly. The electrospring or electrospray, that only 12-15 lakhs, within 12-15 lakhs you will get that machine, and that machine is very easily you can prepare these nano bioformulations.
Okay, sir. Thank you so
Thank
much.
you, sir. Thank you, sir. So one more, sir. So these nano bioformulations are compatible with stress conditions in the soil. So.
Yes, of course, that depends on that which nanoparticle you are embedding with which microbes. That is also important, but yes, it is compatible. Normally, it is very compatible.
Okay,
Thank you
so
so
much. Director STP के नाम से जो शो रहे हैं.
Yes.
जी.
My question is, can we blend compost or vermicompost with nano fertilizer so that a nano compost is prepared?
I think it is possible. I have never tried, but I think it is possible.
So we can make nano compost by blending this nano fertilizer with the compost and vermicompost.
Yes, but you have to be sure that no earthworm is involved there inside, because otherwise it may adverse effect. We don't know that earthworm. But after making the vermicompost, then you can go for this blending with nanoparticle.
Like in case of mushroom farming, after the mushroom is taken out, the substrate, it is called SMS, spent mushroom substrate. When you take out that spent mushroom substrate and decompose it by using decomposer, that becomes a compost.
Yes.
I'm not talking about vermicompost. I'm talking about compost of substrate. And these compost, if blended with nano fertilizer, will become nano compost?
Definitely, when you are blending with nano fertilizer.
So this will be useful?
This will be useful.
So can we prepare nano fertilizer in a small scale?
That you can do. That depends on your that size, bioreactor size.
So by investing 15-20 lakhs rupees, we can set up a nano fertilizer unit?
Yes, provided you have these two instruments you should have nearby. Because when you prepare immediately, you have to test, regularly with this particle size as well as stability.
Okay, so those two instruments which are most useful means what is can you give a business model of preparing a small size nano fertilizer?
सर मैं आपसे रिक्वेस्ट करता हूँ, मैं आपको मेल आईडी दे दूंगा सर, आप उससे बिजनेस मॉडल का आप उनसे उस चीज में डिस्कस, क्योंकि एक्चुअली टाइम ऑलरेडी ज्यादा हो चुका है सर.
ठीक 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 कह रहे हैं नीरज जी।
एक्चुअली क्या मेरे को सभी को लेके चलना है साथ में सर।
बहुत बढ़िया, बहुत बढ़िया।
अनूप सिंह जी
जी सर
पूछिए।
गुड इवनिंग सर।
Good evening.
Sir, I want to ask you about this leaching and emulsification of the urea, nitrogen in the urea. What about in the case of this nano urea? And my second question is, can we use nano urea in organic cultivation? This is only my questions. Thank you.
No, that you can use this, but first of all, your particle should be nano size, and they are preparing nanoparticle through chemical method. It's a chemical method. The particles normally they are naked. I told you. If you look at if you could prepare nano urea with biological method, biosynthesis with microbial protein, then it will be naturally encapsulated, and definitely that will be stable, and that you can use it.
Okay. And what about the emulsification and the leaching of nitrogen in case of urea, and what
Yeah,
in
that will reduce, definitely considerably reduce, at least 80-90% leaching loss you can prevent. That is possible.
Thank you.
That
Thank
is
you.
possible.
So nice, sir. So nice. Thank you.
इसके अलावा गुरमूर्ति जी, दामोदर जी एंड विनय जी का हैंड रेज है। क्या उनका कोई क्वेश्चन है तो वो अपने आप को अनम्यूट करके पूछ सकते हैं, नहीं तो हम इसको फिर कंक्लूड करते हैं। और किसी का अगर कोई क्वेश्चन है तो वो अपने आप को एक एक करके अगर पूछना चाहते हैं एक अनम्यूट करके वो पूछ सकते हैं, फिर नहीं तो हम इसको कंक्लूड करें। आई थिंक किसी का क्वेश्चन नहीं है, और मैं चाहता हूँ कि एक बार आप लोग अपना वीडियो ऑन कर ले ताकि हम लोग एक फोटो, एक स्क्रीनशॉट, एक फोटो ले ले, जिससे हमें यादगार रहे कि हम लोगों ने जो 15 अगस्त बनाया था और एक स्पेशल सीरीज की थी उसमें हम लोग सब प्रेजेंट थे। एक बार आप सभी से निवेदन है, एक बार आप सभी अपना कैमरा ऑन कर लीजिए ताकि सबकी वीडियो आ जाए, तो उससे क्या हम लोग को एक यादगार पल की हमने 15 अगस्त 77 इंडिपेंडेंस डे पे हमने एक टॉक सीरीज की थी, और उसमें हम सभी ने एक बहुत इंपॉर्टेंट टॉपिक जो कि नैनो यूरिया, जो कि अभी सबसे टॉपिक अभी आप लोग हर जगह सुनते होंगे नैनो यूरिया के बारे में, नैनो पार्टिकल के बारे में। तो मैं चाहता हूँ एक बार जो वीरेंद्र सेठ जी हैं, सुशील कुमार जी है, गणपति व्यास है, दाविदार जी, अनूप जी हैं, आप लोग डॉक्टर ओपी शर्मा जी हैं, एक बार आप लोग क्या कि सबका हम लोग अगर चेहरा आ जाए तो हम लोग क्या फोटो क्लिक कर लेंगे जिससे हमें याद रहे 77 इंडिपेंडेंस डे पे हम लोग सब एक साथ थे, एक इम्पोर्टेंट टॉक हमने की थी जी।
वंदे मातरम कहें क्या?
हाँ सब कह देते हैं वंदे मातरम, भारत माता की जय,
जय हिंद,
जय। मैं चाह रहा था बाले सर आपके कोई क्वेश्चन थे क्या? अगर बाले सर आप कुछ पूछना चाहें, क्योंकि मेरे को आपका मैसेज भी मिला था ग्रुप में, आप कोई चीज नैनो के ऊपर कोई चीज डिस्कस करना चाहे बाले सर। सर अनम्यूट कीजिए, डॉक्टर साहब अनम्यूट कीजिए, बाले सर अनम्यूट कीजिए अपने आप को प्लीज। बाले सर आप म्यूट है, आप माइक को अनम्यूट कीजिए, आपकी आवाज नहीं आ रही बाले सर।
मुझे ईमेल आईडी शेयर कर दीजिए, मैं डायरेक्टली कांटेक्ट कर लेता हूं क्योंकि टाइम बहुत कम है।
ओके सर, ओके ठीक है सर। मैं अपना नंबर इसमें इनबॉक्स में, चैट बॉक्स में डाल दे रहा हूँ, बाकी जो आपको पोस्टर मिले होंगे उन पे भी मेरा नंबर है और आप उससे कांटेक्ट कर सकते हैं। बाकी हम लोग हर सैटरडे संडे को पोस्ट हार्वेस्ट एंड ऑर्गेनिक फार्मिंग पे भी सीरीज हम लोग एवरी सैटरडे संडे ऑर्गेनाइज करते हैं। तो मैं चाहता हूँ कि ऐसे ही हम लोग इम्पोर्टेंट जो टॉपिक्स हैं उनको हम वीक के बीच में हम ऑर्गेनाइज करें। और आज ये हमारा ये उद्देश्य था कि जो हमारा 70 इंडिपेंडेंस डे है और डॉक्टर जे.सी. तरफदार जी जैसे पर्सन जिनके पास एक वर्ल्ड पेटेंट है, वर्ल्ड में पहले पर्सन है, आजादी के दिन हम उनको सुने। और आप सभी का बहुत बहुत धन्यवाद, स्पेशली डॉक्टर जगदीश तरफदार सर का, जो इतने शॉर्ट टाइम ऑफ पीरियड में सर ने हमारा इन्विटेशन एक्सेप्ट किया और इस चीज को आप सबके सामने, क्योंकि मुझे लगता है इससे आप सबकी बहुत सारी क्वेरी भी क्लियर हुई होंगी नैनो को लेके और आगे भी, क्योंकि एक इंटरेस्टिंग टॉपिक था, क्योंकि इससे पहले नैनो के ऊपर कोई डिस्कस नहीं करता था एज ए साइंटिफिक। तो अगर कोई इस पे वोट ऑफ थैंक्स या कोई रिमार्क देना चाहे तो मैं चाहता हूँ, नहीं तो फिर हम इसको क्लोज करें। अगर कोई इस पे वोट ऑफ थैंक्स या लास्ट में कोई इसका रिप्लाई करना चाहता है कि डॉक्टर गुरमूर्ति सर, मैं चाहता हूँ आप इसको रिप्लाई करें, कैसी आज की ये सेशन हम कैसा लगा आपको? अनम्यूट करके डॉक्टर गुरमूर्ति सर, अनम्यूट करके जी।
Thank you, Dr. Neeraj Kumar ji. It was really a very good session. It is actually apt and the content is really good. And I also congratulate the speaker for delivering a wonderful presentation. So on your part, Neeraj Kumar, you have made a wonderful and active play for making it in whole covering across India. So many people have joined and those interacted. It's actually a lively interaction And the context is so good that meantime, in the recent times, we are seeing a lot of information about the nanofertilizers and its effectiveness and what is their use present context in India, although it is efficient, but how best it can be done. As the speaker and many interacting delegates have also told, dignitaries and all. So that needs more research backup, and that needs more some scientific understanding about the farmers and all, where to use and where not to use. So I congratulate you on behalf my behalf, as well as all the dignitaries, and that was really a good thing. And thank you very much. Jai Hind, and once again on behalf of me. So it is a 77th Independence Day. All Abhinand kar raha hu, all to you and all the people to join here, and then made a fruitful interaction. Thank you very much, sir.
Okay, thank you, sir.
Thank you. What is my request is you make it some kind of say it's, I think it is recorded, so would be useful for somebody in the future. Whatever the actions have been taken, our government also, it may be useful. People have all the brains have joined here.
Yeah, it's recorded and soon we will discuss with Dr. Jagdish and we will share you the link.
You have a good contacts across India to the scientists and
sir, actually just मैं अभी कल actually निफ्टम सोनीपत गया था, अभी डॉक्टर हरिंदर सर ने ज्वाइनिंग किया रिसेंटली, तो मैं कल वहाँ गया था, तो आज सुबह फिर सर ने मेरे को वहाँ रोक लिया था कि इंडिपेंडेंस डे के फ्लैग ऑफ के लिए, तो फिर मैं 11 बजे वहाँ से निकला, 70 किलोमीटर साइकिल से भी चल के मैं 2:30 बजे 2:30 पे मैं घर पहुंचा था। पहुंचते मैंने अभी तक खाना वाना कुछ नहीं खाया, सीधा मैं बैठ गया, तो क्योंकि मैं एक्चुअली क्या था, हमने टाइम शेयर कर रखा था, तो मैं चाह रहा था कि 3 बजे हम इसको ज्वाइन करके इसको करें। और दामोदर सर, आप कुछ कहना चाह रहे हैं क्या? फिर हम इसको
yes, Neeraj, a very trending topic you have selected. Now this topic is necessary to enrich the knowledge on bioformulation preparations, nanofertilizers, nanoformulations. Very trending topic. Thanks to Jagdish Tarafdar sir for delivering a very nice lecture. Thank you. Among all participants, I am very thankful to you. Thank you so much.
Thank you very much.
जगदीश सर, आप कुछ बोलना चाहे हमारे पार्टिसिपेंट्स को, एक लास्ट वर्ड या नैनो के बारे में आप कुछ बोलना चाहिए लास्ट? आज की मीटिंग के लिए लास्ट।
Thank you Neeraj ji. I mean you conducted so nicely, and I am very much thankful to you because I could disseminate my knowledge to you people. I am very much thankful.
डॉक्टर साहब, जब मैं सर,
if you need any help, anybody need any help,
सर मैं आपसे जब
I am always welcome. I am always available.
Sir, your email ID, sir.
You have my email ID, jctarafdar@yahoo.in.
Pardon?
jctarafdar@yahoo.in.
jctarafdar.
डॉक्टर साहब, आप इतना कमेंट बॉक्स में लिख दीजिए, अगर कमेंट बॉक्स में यहाँ पे चैट बॉक्स में आप लिख दीजिए तो सब नोट लेंगे यहाँ से।
हाँ जी सर।
Chat box, where is the chat box? Actually,
hello Neeraj sir, I want to say some about you, sir. Sir, you are a great personality. You are a role model for us.
सर बस आप लोग का आशीर्वाद है, मैं तो कोशिश करता हूँ कि हम सब भाइयों को जोड़ पाए। साइकिल की देन है, साइकिल चक्कर घूम रहा है सबको जोड़ते हुए।
So nice, thank you.
Wonderful.
सर ओके, मैं सर की ईमेल आईडी लिख देता हूँ, अगर एक मिनट।
सर मेरी एक रिक्वेस्ट थी, कोई लिटरेचर या पीपीटी शेयर हो जाती पार्टिसिपेंट को इन डेप्थ नॉलेज।
सर ये जो रिकॉर्डिंग थी ना, ये जो अपन ने पूरी की, तो सर की पीपीटी, क्योंकि एक्चुअली पीपीटी सीधा शेयर करना थोड़ा इशू हो जाता है।
कोई और लिटरेचर कोई तरह इसी तरह का सर के पास कोई होगा तो
सर आप गूगल पे डॉक्टर जगदीश तरफदार जी खाली लिखिए, आपको इतने सारे इनकी जो बुक्स हैं, रिटर्न है, वर्ल्ड फेमस पर्सनालिटी हैं, ये तो आपको पूछने की जरूरत ही नहीं थी। आप गूगल पे खाली नाम लिखेंगे, आपके सर के बहुत सारी चीजें आपको मिल जाएगी।
थैंक यू सर, थैंक यू
सर। ईमेल आईडी आपकी जगदीश
jctarafdar@yahoo.in।
ओके, आपने मेरे को मेल किया, वेट मैं
I have mailed you ना?
या मैं जस्ट वेट 1 मिनट, मैं वहां से आपकी वहां से,
और आपको व्हाट्सएप पे भेज देंगे।
नहीं, मैं एक बार जस्ट अभी भेज देता हूँ, क्योंकि अभी जो पार्टिसिपेंट जुड़े हुए हैं उन तक पहुंच जाए उस चीज को। मैं जस्ट अभी आपको
आप लिखे स्क्रीन में दिखाओ तो आई एक
मिनट वेट।
नीरज जी, आपकी साइकिल हरे रंग की है?
सर हरे रंग की तो नहीं है, लेकिन क्या करें, कंपनी ने जो कलर करके दिया वही है।
नहीं, हरित
हरित है।
नहीं, हरे रंग की साइकिल,
हरित है।
ग्रीन रिवोल्यूशन, साइकिल इन ग्रीन रिवोल्यूशन, ग्रीन
सर एक्चुअली क्या है, मेरे साथ इशू ये हो रखा है कि सारी चीज संभाली, उसको अभी धीरे धीरे टीम वर्क में लेके आना, क्योंकि मेरे को खुद नहीं पता रहता। अभी मैं जस्ट इस मीटिंग के बाद फिर मेरी एक जगह मीटिंग है, वो करके कंटिन्यूटी, और रात को फिर क्या था 10 बजे के बाद फिर मेरे को फॉरेन टॉक के लिए फॉरेन मीटिंग में वो अटेंड करना पड़ जाता है। मेरे लिए वो थोड़ा सा इश्यू हो रखा है टाइम मैनेजमेंट को लेके।
बहुत बढ़िया, बहुत बढ़िया, जय हो।
सर मैंने मेल आईडी लिख दी है डॉक्टर सर की, आप अभी आप लोग नोट कर सकते हैं, jctarafdar@yahoo.in। J for jackfruit, C for cat, T for table, A for apple, R for rat, A for apple, F for fish, D for dog, A for apple, R for rat @yahoo.in।
थैंक यू सर।
ओके सर, थैंक यू सो मच सर, आप सभी का बहुत बहुत धन्यवाद। फिर हम मिलते हैं नेक्स्ट संडे को, हमारी जो ऑर्गेनिक फार्मिंग की जो हमारा फाउंडेशन है हरित प्रदेश एग्रो फाउंडेशन, जो कि 120 पार्टिसिपेंट्स मेंबर हैं, जिसमें 5 वाइस चांसलर्स हैं, फॉर्मर, और कुछ 5 आईसीआर के डायरेक्टर्स हैं, इंटरनेशनल साइंटिस्ट हैं, और इसमें 40 रिसर्च साइंटिस्ट हैं, रिसर्च स्कॉलर्स हैं, फार्मर्स हैं, और प्लस अभी हमारे साथ में जो ग्रुप में जुड़े हुए हैं फॉरेन से भी हैं। हमारा रशिया के साथ कोलैबोरेशन है सोइल हेल्थ को लेके, फार्म स्टेट एग्रीकल्चर इंस्टीट्यूट, तो हम लोग कुछ इंटरनेशनल कोलैबोरेशन के साथ भी रिसर्च करके काम कर रहे हैं। और बाकी अभी हमारा अभी कल मैं निफ्टन में डॉक्टर ओबराय सर से डिस्कस करके आया हूँ, तो अब हम जैसे हमने ऑर्गेनिक फार्मिंग का एक मिशन चलाया था 4-5 साल से हम लोग कर रहे हैं, अब जो मिशन होगा 15 अगस्त से, अब हम इसको मिशन प्रोसेसिंग एंड वैल्यू एडिशन पोस्ट हार्वेस्ट पे अब लेके इसको प्रमोट करेंगे, जो आने वाले 3-4 साल जो हम लोग पूरा डेडिकेटेड प्रोसेसिंग और उस पर काम करना है। ठीक है सर, ओके, थैंक यू सो मच।
थैंक यू वेरी मच।